When you plug in your electric car, you're probably just thinking about getting that battery topped up, right? But behind that simple act, there's this incredible, completely invisible dance of technology and safety going on. Today, we're going to pull back that curtain and look at the unseen rulebook that makes it all work. I mean, really think about this for a second. At a DC fast charger, you could be dealing with up to 1,500 volts. That is an insane amount of power. So how can you just trust that when you plug that cable in, everything's going to be okay every single time? What's stopping this from being just unbelievably dangerous? Well, the challenge here is huge. You've got cars built in Germany, chargers coming out of Korea, and they're all hooking up to power grids in, say, California. Different companies, different designs, all over the world. How on earth do you make them all connect and communicate perfectly? Without some kind of common set of rules, it would just be total chaos. And that's where the hero of our story comes in, IEC 6185123. Now, that might sound like a boring technical name, but this is the international standard that sets the rules for DC charging. You can think of it as the master translator and the head safety engineer for the entire global EV world. So how does it actually do all this? Well, the first big thing, the most crucial role of this standard, is to create a common language. Right. This standard makes sure that it doesn't matter where your car was made or who built the charger. When they connect, they speak the exact same language. They can negotiate how much power to send, they check that they're compatible, and they manage that whole charging session from start to finish. It's all about making sure everything works together seamlessly, anywhere in the world. Okay, but getting everyone to talk to each other is really only half the battle. The standard's number one absolute top priority is making sure you're safe from all that electricity. It's easy to look at a 380-page technical document and think it's just for engineers. But it's not. Every single rule, every test, every requirement in there exists for one reason and one reason only: to keep you and your car safe. The way the standard does this is with something I like to call a triple safety net. First up, you've got basic protection. That's simple enough. It's just covering up and insulating all the live parts. Then you have fault protection. That's the backup plan in case that first layer of insulation somehow fails. And finally, there's enhanced protection, which is a layer so tough, so reliable, it's like having two totally separate safety systems working together. Let me give you a specific example. There's a key safety rule that says every single metal part of the charger and the car that you could possibly touch has to be connected together, and then connected to the ground. Why? Well, it's so that if a fault ever happens, the electricity has a super easy, safe path to follow into the earth, instead of deciding to go through you. It's a vital concept, and the engineers call it protective equipotential bonding. Now, beyond just raw electrical safety, the standard also maps out the whole architecture for how these chargers and cars actually talk to each other. So when you plug in, the car and the charger start having this really sophisticated digital conversation. They're swapping data on your battery status, its temperature, all that good stuff. But here's the really clever part. The standard says the most critical safety features cannot depend on that digital chatter. The core safety systems have to be separate, hardwired in. This makes sure that even if the communication software crashes, the physical safety layers are still there. It's like a brilliant trust but verify system built right into the hardware. The standard is also really flexible. It allows for a few different dialects, if you will. It outlines three main systems. System A often uses a dedicated data line, which is common in many vehicles. System C, which is popular in Europe and North America, does something really smart. It sends the digital signals over one of the existing low-voltage control wires, a method called power line communication. The point is, the standard lets these different methods exist, but it makes sure they all operate safely under the same master rules. Okay, so we've got the rules for the language and the safety. But how do we know any of this actually works in the real world? Well, the answer is relentless, punishing tests. And when I say punishing, I mean the testing is absolutely brutal. This list here is just a tiny sample of what these chargers have to go through. They simulate everything you could possibly imagine. Take the cable breakaway test. That one checks what happens if someone freaks out and just drives away while they're still plugged in. The charger has to cut the power instantly and safely. Every single one of these nightmare scenarios has to be passed before a charger can get certified. And finally, this standard isn't just about how we charge today. It's actually building the foundation for the entire future of energy. So, we all get forward power transfer, right? That's just electricity flowing from the grid through the charger to your car. Easy. But the standard also clearly defines the opposite, reverse power transfer. And that's where things get really interesting. This is when electricity can flow out of your car's battery and back to the grid, or even to your house. This reverse power transfer idea is the key that unlocks what we call vehicle-to-grid technology. And because the standard spells out all the rules for how to do this safely, it's paving the way for a future where your car is way more than just a car. It becomes a mobile power station, basically a huge battery on wheels that can help support the grid or even provide backup power for your home during an outage. And thanks to this hidden rulebook, IEC 61851-23, that future is a lot closer than you might think. This whole complex web of safety rules, communication protocols, and intense testing, it ensures that when you plug in, you're not just charging a car, you're plugging into the future of energy. So the question really isn't if anymore, it's just when.